Okay, guys, next problem. Problem 25, the Trendelenburg position. You have an emergency with major blood loss. The doctor will order the patient placed in the Trendelenburg position, in which the foot of the bed is raised to get the maximum blood flow. So the feet is somewhat at the top. Blood flow to the brain. If the coefficient of static friction between the typical patient and the bed sheet is 1.20, so you have a bed and inclined bed um, because of the Trendelenburg position and the friction. Now there's a friction because the problem is frictional forces. This is what makes the problem really messy. Actually, this is the problem with laboratory because for us really to grasp, because from the day we were born till the day we die, we are we're always in constant reacting with friction. That's why we can't understand really physics. Really, it's because of frictional forces. So that's what makes this really messy in the dynamic side. Anyway, so coefficient of static friction, so meaning static meaning it will not move, but it will have the tendency to move. As you can remember the formula for static friction, that is you have a less than sign, so meaning that is from a particular zero to a particular maximum value, that frictional force will occur before it slips, or from this case before the patient slips. Of course, if the tilt is too much and that static friction will be exceeded, your frictional force will not counter that weight and it will slide down. So that is the lesser than sign or the greater than sign. Okay, you just look at the formula. What is the maximum angle at which the bed can be tilted with respect to the floor before the patient begins to slide? So may I first draw the problem? Of course, I'm not a civil engineer. I was not waray ko karaw ta civil engineering. So natik mo pa mag-drawing. Pasensya ka kita drawing. So I'll just of course draw my bed like that, or maybe I could try more, and I can draw my patient just like this. Of course, having that Trendelenburg position. Oh, parang lumiliad. Of course, that is this one is the maximum angle. Meaning, if you exceed that angle, that patient will now slip. Okay. So what is given? The frictional friction. I mean the muse of S. This is actually constant. Actually, this one is being measured even in, or we can expect that these are being measured, of course, for those with a concern about slipping. For example, those that are with tires, those are working with tires, those engineers working with anything with regards to friction. Of course, they should calculate this one. This is a constant for surfaces in contact, of course. So given from the problem that is 1.20. So what is that maximum angle na pang ginataga problem? Oh, only the 1.20. And when we were asked, what is the maximum angle? So I guess the problem is we should calculate it in terms of M, in terms of F, whatever may be. Whatever constant there is, okay? Maybe M. But anyway, we can analyze. So before, if the problem is before it slips, so that problem talks about acceleration is equal to zero. And we have a case of first Newton, Newton's first law. Okay? Meaning the summations of forces, um, we can tilt axis or we may not. It all depends on how it would be easy. I've already shown you um, techniques how to tilt. There are problems sometimes it can be easier if you tilt. Sorry. Mm. Ah, Anyway, summations it is equal to 0 because that is before it slips. Then we can probably analyze the forces. Of course, you have a weight which is going down. Um, of course, you can draw that weight. That is the weight of the patient, which is in mg. You have the normal force, which is normal with the incline, 90 degrees with the incline. So that's why we call them normal force, N. And you know your N is somewhat connected to your frictional force. There is a frictional force holding that patient that will not slip, of course. So that should be going up. Okay. So this is your frictional force, F. So what other forces? I think there is none already. And then probably the theta. We have to represent where is the theta here. Actually, the theta should be on this side. So if that is on this side, okay, if that is the theta on this side, so that theta actually is on this side. That is actually the theta. Okay? Theta, the opposite, and then you have again 90. That should be theta actually also. Okay? So, you have a summation. If we tilt axis, what are we going to solve? The angle theta. So, maybe we can, do we have to tilt? Do we have not? Anyway, for example, we will tilt. This will be our positive x-axis. Okay? So, summations on forces on x now is equal to 0. Those that are going to the right is actually this. Your W is going to the right. Your N is normal, so it won't have um, it won't have any bearing on the X because it's tilted axis. So what is going to the right is W actually. Is it tilted? Yes, it is. This is the opposite angle. So we need this angle here, so that is the 90 minus theta. So you will say that is W. Since we're talking about X, that should be a cosine, but the angle is 90 minus theta, of course. Actually, we know that cosine 90 minus theta is actually equal to your sine theta. You can have a sin cos cosine for that. Why? You can have a cosine again. I've already told you this. Cos cosine sin, sine cosine 90 minus theta actually is equal to cos cosine sin. Cosine 90 cosine theta, and then you have a negative, so that would be a plus, cos sin 90 sine theta. And you know your sine theta for your sine 90 degrees is sine 90 degrees is 1, while cosine 90 is cosine 90 is because you have a 90-degree angle, that should be 0. Anyway, you can type it to your calculator in case where duda happens, 0. So this one becomes 0. So you are definitely left with sine theta. So that's actually sine theta. Okay? We can change that one to sine theta. W cosine 90 degrees minus theta, or W sine theta. W sine theta. And then what is going to the left is of course your frictional force F. Okay? Your frictional force and your N is somewhat connected. Maybe we can simplify this more. My pen is somewhat uh, dire, dakmol. So that would be a W sine theta minus F. And then you would plug your summations of forces on Y. Summations of forces on Y is equal to 0. You would have a N and W. Okay? Your going up is N. And that should be an N. If you tilted axis, then that should be N. And then your W is somewhat the opposite of that. That would be a W cosine theta. Again, that is the opposite angle. So we use cosine for the Y because that is the opposite angle. Now, you have a connection between F and N with respect to your F120. It states from the problem, from your formula, that Fs is lesser than your values of μs of S and then your N, fun. Okay? But again, that is from 0 to a particular frictional force. Okay? So you can equate that one, meaning you're aiming for that maximum frictional force it can hold. So that it should be a mu s n. Okay? So meaning you can replace this with somewhat n, or probably this one with n, and probably solve for the theta because you have already your w. I think it can already be solved. You have here from that side, you have a w sine theta is equal to f, and then you can replace your f to be your mus sn. Okay, so what is your mus sn? So that is 1.20, and then you will have your n to be at this side. Your n here is equal to, since it's equal to 0, n is equal to w cosine theta. Okay? So, actually, your aim here is to arrive at theta because you're solving for that angle. So that's why you should make equation, and then finally you will arrive at theta by using what is constant, like w. W is constant. It may not have a number to it, but it should be um, when mass is given. Usually mass is given from a applied type of problem. So it should be resolved in W. So 1.20 n. So n is W cosine theta. So this is equal to W sine theta. So you can actually cancel the W since it both appears. And then you can divide the sine theta with respect to the cosine theta, and that would equal to 1.20. And that would be a tangent theta is equal to 1.20, and that theta is equal to the arctan of 1.20, which happens to have a value. That is the maximum angle. So whatever the weight may be, so there's a maximum angle. You could just imagine that there's nothing given, but um, meaning the theta is not dependent on how what is the mass of the patient. It doesn't matter if it is mabugat, matambok, butete. So it doesn't matter. What matters with respect to the theta is the frictional force, that 1.20 over here, which is being measured. Okay? So that's how you should think of this problem is in terms of an application so that you can really learn. Okay? Arctan 1.20, and it will give us that maximum angle to be 50.2 degrees. Ooh, 50.2 degrees. Okay? Thank you guys for listening. So maybe I have to cut since it will be long if I will continue. Thank you guys.